in this lesson, we want to start taking a look at the mean average. Now, when people say find the average, this is what most people think of. This is when we add up the numbers. And then we divide by how many numbers we have. So it's not so much the issue of how to do it. The question is, when do we use it? Why do we use it? And there's a time and a place for this. You have to understand there are three different averages. There's the mean, there's the median, and then there's the mode. So there are three different things. And I remind people it's like this. All three of them are averages, but yet they're each its own tool. Think about it. If you want to dig a hole out in the backyard, you have different tools to use. You have a shovel, you have maybe a pick, and maybe like a digging iron. All three could dig the hole. But depending on the situation, if the ground's really hard or if the ground's really muddy, one of the tools is going to be better for you. It's the same here. Three averages, they each work to find the middle, or the average. And I do want to put that here. Because that's the whole purpose of all of this, is to find the middle. And again, why do we find the middle? We find the middle so we as humans can judge where things are for us. For example, if you knew the average of a test based on a class, the class average is a B. It would be nice to know that because I could look at my test and say, oh wait, I got an A, that means I'm better than average. Or if you got a D, oh, I'm below average. We want to know averages so we know where we fit in. We know, am I above, am I at least average, or am I below? Now there are some cases we want to be below average, okay? Or we want to be above average, depends on the situation. But we need this so we know where we fit in. So with this will always find the average for you. But there are times when this doesn't work right. Just like using a shovel on very, very dry, hard ground. A shovel does not work very well to dig a hole. So let's look at a couple examples here, see if we can't show you when this doesn't work. So I'm going to take a list of data. My question is this: what's the average age of a 7th grader? So I asked 5 people. These are the answers I got. 12, 13, 13, 12, 12. So I ask you what the average age is. Okay, if I do the mean, I would add all of these up and divide by 5. 1, 2, 3, 3 12s, 36 plus 26. Now just a quick note, it does help to write down your sum. I add all these up and I get 62. What a lot of kids do is they forget this, and then they forget what they divided by. Or they try to type everything in at once. They do 12 plus 13 plus 13 plus 12 plus 12, and then they divide by 5, and their calculator's all messed up. You know why, by the way? Because when you do 12 plus 13 plus 13 plus 12 plus 12, divide by 5 on your calculator, it does order of operations. You know what calculation it's going to do first? It's going to do the division first. And then it will add. That's why it gets messed up when you type all of it in at once. Add these up, you must then hit equals and then divide by 5. So I have my sum, divide by 5, which is how many numbers I have. Most times you don't get a whole number, so it's easy if we just pick a number to round to. Let's round to the nearest 10th. So I did take 62, divide by 5, and I get 12.4. Now how do we judge if something works? The mean average is supposed to find the middle. Not the lowest, not the highest. By the way, they like way low and way high would be outliers. And by the way, there's no outliers in this list. So we want the middle. Is 12.4, which by the way is almost the same as 12.5, is this halfway between the 12s and the 13s? The answer is yeah, it is. It is. This works. Why does this work? And kids will say, because you used all the numbers. because this is how to do average. Remember, there are 3 averages, mean, median, mode. Why does this one work with this set of numbers? Here's why. The mean works when all of the numbers are all close in value. Look, they're all roughly the same number. That's when the mean works. The ground's nice and soft, you dig your shovel in, you get a chunk of dirt out. That is what a shovel is used for. Soft ground that you can dig into. This is what the mean is for. When all the numbers are pretty close together, the mean works great. I'm going to leave this up. Let's take a look at when the mean doesn't work. I'm going to use the same 5 kids. 12, 13, 13, 12, 12. And I'm going to include one more kid. Me. 40. So, here's 6 kids. 12, 13, etc. and 40. Again, I would use my calculator. Now, I already did my sum earlier, 62, and I'm going to add 40 to it. So I get 102. What do I divide by? Most kids say 5. That's not right. What do I divide by? 6. This is my sum. Divide by 6 now, because 1, 2, 3, 4, 5, 6, which is my numbers. And remember, if this is going to work, my answer should be somewhere in the middle of these. I have to reset my calculator real quick because it got messed up. Now, before I do this, I do want to say something that I missed. Does the answer make sense? Does it make sense that the average age of a 7th grader is 12 and a half? Does it make sense that this works? It should. And I forgot to mention that because that's going to pay off here in a little bit. Okay, back to where we were, 102. And resetting my calculator again, I don't know why. There we go. 102 divided by 6 equals. Now this actually worked out to a whole number and I get 17. Now ask yourself, does this make sense? Does it make sense to say the average age in this classroom is 17? If it does make sense, that means on average, most of you are driving legally. I don't think this makes much sense. This doesn't make sense. This makes sense, this doesn't. What's the only thing that's different between this list and this list? Me. Why is this one number so different? Well, what do we call a number that's a lot higher or a lot lower than everything else? It's an outlier. So, to wrap this up, does the mean work when there is an outlier in the mix? Does it give you an answer that makes sense? No, the average age isn't 17. An outlier takes this and breaks the tool. It's like a very hard ground and you're trying to dig in with a shovel. And you're standing on top of the shovel and it's not going in. It breaks it. So here's what you have to understand. The mean is very good and it works very well when all of your numbers are pretty close together. Why? Because it gets an answer that makes sense. It gets an answer that's somewhere in the middle. Where it doesn't work is when there is an outlier. As soon as you put an outlier in, it breaks it. It takes the number and makes an answer that doesn't make sense for the numbers that you were given. Okay? I hope that makes sense. Add them up, divide. I can only use this tool when there's an outlier. Good luck.